Hi everybody, and welcome back to another episode of Magnificent Math with Mrs. Murray. Bum, ba, bum. Today we are going to be looking at solving systems of equations graphically. So what I mean by that is with using technology basically. So two choices that you have is to use your graphing calculator, which you should always have with you, and your other option is to use an application like Desmos um, and insert your equations on something like that. Only problem with using Desmos is that you can't use it on a test because the only way you can access it is on your phone. So I would recommend getting in the habit of using your graphing calculator because it's a good skill to have. You will need that same skill moving forward to next year too. So basically what's going to happen in this section is that there's going to be a system of equations, and this time we can either have a linear quadratic equation or a quadratic equation. So you should have done linear and linear equations in grade 10. So some of this might sound a little bit familiar, but if we're thinking about a linear quadratic equation, just want to take a minute for us to think about the different ways that the systems could look like. So if we take our first situation, we can have a quadratic equation opening upwards, or this could have opened downwards. Well, could have opened downwards, but this part would have to move. But in this situation, you can see that we don't have any overlap here. Okay, so that's one situation that we can have. Second situation that we could have is a situation in which our graphs touch just once. So there shouldn't have been a gap there. I kind of tried to cover that up, but you can clearly still see that. And then the last situation is where the two graphs intersect twice. Okay, now again, I kind of mentioned this earlier, but these graphs can open upwards or downwards. So if this opened downwards, it would just move down onto this side of the graph. If this opened downwards, it would be found down here. And then this one can open downwards and it would still intersect twice. Okay, in our quadratic situation, we can have two quadratics that don't overlap. We can have two quadratics that meet right at the vertex, or we can have two quadratics or parabolas that intersect. Why does all of this matter? Well, it matters because when we're looking at the system of the two equations, the solution is going to be located at the point in which they either intersect or touch, basically. So if we think about this situation here, there's actually going to be no solutions for that system of equations, and that's a possibility. Okay, there might be times where there is no solution. In this case, there would be one solution, and in our last scenario here, we would have two. Over here, again, we have no solutions because they're not touching. Over here, we would have one because they touch only once, and down here, obviously, if I can find it, there are two solutions. So the answer to the next question, what is the solution to a system of equations? Simply stated, it's the point in which the two equations or graphs intersect. Okay? So as I mentioned earlier, this whole section is going to be focusing on using technology to graph this. I'm going to pull up the graphing calculator and show you how we're going to go about doing this. So first things first is we've got to recognize we have a linear situation and a quadratic situation. I know this is linear because x is just to the power of 1. X squared being to the power of 2 gives us a parabola for the second equation, making it a quadratic. So what we have to do first is we have to rearrange the equations. This is supposed to be a 1. It looks kind of like an I apologize for that. So moving the y over to this side, we get y equals x plus 1. And then we're going to leave the y here and move everything else over to the other side because we want that y to stay positive. So y will equal negative x squared plus 6x minus 3. So now what we have to do is use our graphing calculator. So first thing you're going to do is turn it on, and you're going to hit your y equals button. If you have some graphs in there from before, you're just going to have to hit the clear button to clear that away. So we're going to start by entering our linear equation rather, which is x plus 1, and we'll arrow down. Then we're going to enter the second one. When you're entering the negative, please make sure you use the negative and not the subtraction sign. There is a big difference between those two buttons, obviously. So we have negative x squared plus 6x minus 3. From that point, we're going to hit graph, and we see how these two graphs are pictured. So we've got our linear equation here, our quadratic here, and we can see they intersect 2 times. So we know there's 2 solutions. So what we want to do at this point is try and figure out what these points are. And sure, we can estimate, but our estimations most likely are not going to be very accurate. So in order to do that using the calculator, we hit our second button and then trace. And we want to find the intersect. So we're going to click the 5 button. And then we're asked if this is the cursor is on the first curve. You're just going to hit enter because it is. Then you'll notice it bounces to the second curve. You hit enter. And then it's asking if it wants us to guess an intersect, and we're going to say yes. Now, this is a calculated guess, and this is what our actual solution is going to be. One of them is going to be 1, 2. Now, we found this intersection point. Now we need to find this one. So we're going to do the exact same thing. Hit second trace, and then 5. And now what we need to do, though, is we need to use our arrows, and we have to move our cursor a little closer to the second point of intersection. So we're going to move it closer and we're going to hit enter. Then it should automatically bounce to the second curve and we'll hit enter. Then it asks us to guess. And we can see that our other intersection point is 4 and 5. So our x value is 4, our y value is 5. Okay, I'm not going to show you how to verify this. It says to verify, but in order to verify, we're just going to take the x value here, substitute it in here, x value here, substitute it in there. So what we do actually end up with is a super easy check for this one. This would be 2 equals 1 plus 1, so 2 equals 2. It does verify. Okay, so to verify, it would just be substituting your answers in to that original expression to make sure that it does in fact equal. Okay, moving on to the last expression. This one's this one's a little bit harder because we have to determine what the equations are for this graph. Okay, we're not given them. So basically, we've got a guy jumping from this beam over to this beam, and they're high-fiving each other in the air. So we need to determine the system of equations that models the performer's height, solve it, and then interpret the solution. So first thing that we have to do is find the equations, and we're going to use the form of y equals, this is vertex form, a x minus p squared plus h. So you might have used h and k here, but either way, this is our x value, this is our y value for our vertex. Okay, so we're going to substitute in things that we know. So looking at our first performer here, our vertex is located at 0.75 for x and 4.5 for y. So we substitute 0.75 in for p and 4.5 in for q. And then we're going to figure out, we want to solve for a. Okay, the graph starts at this point here, 0, 0. So we can use that point to determine a. So we just substitute 0 in for y and 0 in for x, and then we're just going to continue solving for a. So going through our algebraic solving skills, okay, what we're going to end up with is a equals 8. Now you can see the first graph and the second graph, they have the same width. 0 and 1.5 is, it's spanning 1.5 meters, and here's 1 to 2.5. So they form the same shape. They're just located at different start points. Okay, so a is going to be the same for both equations. So now that we've found a, what we're going to do is we're going to substitute this a value in for right here. Okay, so we're going to put it in right there. And so this is what the equation is going to look like. So we would have y equals -8, and then x minus 0.75 squared plus 4.5. This a value is going to be the same for our second equation, okay, but our vertex is going to change because it's located at this point. So the height, or q, is still the same at 4.5, but our x value is going to be 1.75 here. And we can just take those and substitute them in for P and Q. So we end up with negative 1.75 and 4.5. The reason these are both negative is because it's always given as a negative in the standard form. Okay? So from there, we would do the same thing. We would use graphing technology to solve, and we would substitute these two equations in. So I'm just going to move this over here. I'm going to go to our our y equals. I'm going to clear both of these. So I have negative 8 bracket x minus 1.75 squared plus 4.5, and then negative 8 bracket x minus 0.75 squared plus 4.5, and we're going to graph this. Okay, and you can see that it's graphed for us. So if it only intersects once as well, you can see that. So we can trace this intersect, and we only have to do it once. So we do our enters, and it will guess for us. And we find that the intersection happens at 1 and 0, but that is incorrect. Okay, sorry, once again I made another error here, and you should be able to, hopefully you can see, here I hit the negative sign as opposed to minus. So now I'm going to graph this. That looks a little bit better. Now I'm going to trace that. And we can see that our intersection here, this makes a lot more sense, is at 1.25 for x and 2.5 for y. So we're asked to interpret the solution. And basically what happens is here we can say, like, what are we talking about at that point? So we can say that the performers cross paths, the performers high five, so maybe they high five. So they high five at 1.25 seconds at a height of 2.5 meters. So that's what the interpretation of that solution would be. Okay, so sorry for all the errors in the video. It wasn't the best video that I put together, that's for sure. But I guess it's good so that you can see just how easy it is to make those mistakes, especially using the graphing calculator. With that being said, good luck with the assignment, and we will clarify any misunderstandings that I may have created tomorrow in class. Have a good night.